Hello everyone. Today we are going to learn about Python generators, a powerful and memory efficient way to create iterators. You might already know about Python functions that they use return, but generators use the keyword yield instead of return. Let's understand how they work. First, we need to create a folder. Basically, I didn't need to create a folder because I have a Python folder. First, open your VS Code or your code editor where you run your Python. Let's I deploy my folder here. Basically, not deploy, it is drag. Uh, I need to cover it in basic folders. So, why didn't work? Maybe it's wrong. What happened? Yes, let's work. Let's create a folder. Let's create a folder. Name generators. Where is the folder? Generators. Oh, it's little bit slow. Why? Get fast videos. So it is first example. One basic of introduction. Basic is introduction. Dot py. A normal function versus generator discuss करते हैं पहले we need to create a normal function. Let's create a normal function. Name normal function. Don't see the suggestion is it uh, see I created normal function. It is not generator. I just show you the difference between generator and a normal function. For I in the range, let's see 5 again result that append 5. We use keyword return. You already know about Python functions, so it use return to return someone, return something, and print. Our indentation is little bit wrong, so normal functions double. It's good, but indentation is here. It's first goes wrong. Here single L. Here also single L. Return result where what goes wrong? It's not inside. For loop also not inside. Now it's correct. Indentation is very important in Python. Let's run it. You see, it always happen 5 times as we give for I in range 5. It give 5 times 5 in an array basically. So in this normal function, we create a list. It is not array, it is a list as you see. In this normal function, we create a list storing all numbers and then returning the entire list at once. When I run this, it gives list at once. It not give one by one. It store once for loop is work, once for loop was run. It store 5 here, but it didn't return. It didn't print instantly. When the loop is work 5 times, after this it store everything, and after it store everything in the result, it returns result once. And when it return result once, after that you will see in once it is printed. So this takes memory for all 5 numbers at the same time. But what if we want to generate one value at a time? But if I want for oh, in every iterations the 5 was printed. In first iteration, what is stored in result it was printed. Then second iteration is just printed 2 5. In third iteration it was printed 3 5. Like that. It was by this basically uh, it is basically generator when you want to print everything one by one. Basically it generate, it's not give once what is stored in result, it give one by one. So uh, but uh, but without storing all in memory, if I want to uh, generate one value at a time, that's why generate comes in. Generate function using yield keyword. When you use function, it is used return keyword. But uh, when we use generator, it is used yield keyword. Let's create a generator using yield keyword. It is function. So clear your terminal, your code editor first, then create a generator. As we create generator function, name it generator function, and for I in range, same program, but I use generator instead of function. Yield I. When we use yield keyword, when we use yield keyword, it is basically generator. It didn't give one at a time. It didn't give uh, all at a time. It give once in a time. So yeah, why it gives error? I didn't understand. I in range 5 li. Let's go ahead. Let's gen. So gen, we call the generate function right now. Print. When we use generator, we use next to call, because I will show you say you later. First let's run that first. As we use 5 times, and every it print once, let's it print 5 times, because let's done. The next when if we call next again, print next, what happened, it called stop iteration, because there is only 5, range is 5, so that it stop the iterations when you print it. what I write. Yes. So that's it. Here, so we use the keyword yield. This means the function does not run all at once. This is time we call next. This time we call next. It continues from where it left and gives the next value. Once all values are done, it raises stop iteration error. So where it gives error, I didn't understand, but here we use the keyword yield. Is there any spelling mistake? Yes, basically this is spelling mistake. Yield. Now it is correct. Let's run it. Uh, so here we use the keyword yield. Yield is important. We didn't use return. We use yield in generator. This means the function does not run all at once. Each time you call next, it continues from where it left and gives the next value. Once all values are done, it raises a stop iteration error. Let's run it first. Where's next gen? The gen is not defined, but the gen is already defined. Length. Did you mean length? What is length? Right, gen. It says length. Outline one. Yes, it gives uh, 0, 1, 2, 3, 4. Yes, as I say, it is not an error basically. When I say it is gives stop iteration, when I print the last one and try to basically try to print the last one, it gives stop iteration, and the range is 5. So if it is printed from 0 to 4, let's give you another example. As again run it, as I, if I give here, we can see how it works. Time sleep, time dot sleep, sleep one. That's I can show you how it runs one by one basically. The time is not defined. Why it says the time is not defined? Just that if yes, but it's not working. Uh, Foreign range. This, this got it. Oh, we need to import time. So input time. Yeah. What happened here? Let's see. 0, 1, 2, 3, 4. Let's show you another example. As you see here, it is also div generator function. Five here also will I let's see the spelling as value in generator function. Print value. See yes, what happened here? What will happen here? Instead, as you see, instead of the next keyword uh, did, I can see here. Instead of using next again and again, we are using next again and again. So instead of next for again and again, we can use a simple for loop. The loop automatically call next for us and stops when the generator ends. So let's run it. As you see here, here we also give time delay, time that sleep for sure. It is actually comes one by one. For import time, yeah, same problem. Oh, yes, now it working perfectly. Yes. So instead of using next keyword, we can use the loop also, because the next keyword also do same thing, but this loop does. So at the same problem, we can create another file, because in the same file we didn't need to write code again and again. Py. Let's show you how it is memory efficient. So import sys fast def nor- normal function. You see, we use return in normal function, but in generator we use the next keyword instead of we use yield keyword instead of uh, return. So in generator, remember it, keep it in mind. I use generator, use yield in generator for I in range, and let's create a generator function, and we can see I use yield keyword, and for printing one by one I need to create I need to print next also. uh, if you didn't want to write next, I can use the for loop also, as a for I in range n will I. It is also correct, but why it's n is not divine, it is not required now. Print size if normal function. normal list. It is uh, it is stored in the list, so I can see. Let me get list instead of function. Normal list and generator function. No, generator numbers. Oh, what happened? There's numbers. As it generate numbers one by one, but in functions, it is stored in a list. You can I for I in range instead of store as a first. In first, I create a result variable, then store one by one in the result variable to get a list. You can use this method also. It is efficient and good for writing. So here I'll print sys dot get size of normal list. You can see normal list and here there 10,000, and same for generator 10,000. So now as it is byte, so the memory arranges bytes. Bytes. Now it's correct. See the code again. Is there any errors? No. Fine. Fine. Input system. Here I didn't need to input time. I didn't any sleep because we just want to print it the size and check how the generator is better than function. But remember, the function has its own working and the generator has its own working. Here error comes. Here an error comes in picture. Why? What it says was not closed violence. It wants to say was not closed means it is not required. Hey, here I forget comma. Now it's didn't show any error. So run it and see. Oh no, normal list, normal list generator numbers. Oh, we need to pass in here. Oh, what? I need to pass in here. So now it's good. Yes, you see. Oh my god, there's a huge difference. Size of normal list is 85176 bytes and size of generator only 200 bytes. Why? Let's divide it. Open calculator. Calculator says what is the number? 85176 divide it 85176 divided by If one takes 8.5 bytes, it goes the wrong way. But you can see uh, what happened here. Let's run again. This normal list takes 85176 bytes, and the generator takes uh, only 200 bytes. So here we can clearly see the memory difference. The list holds all 1 million numbers at once, but the generator one only produce one number at a time, saving huge memory. That's why generator is used when working with large data streams. So we can again see the generator expressions, how the generator express. So again get a another file, uh, three introduction, as it is the introduction. So again we need to create another list, x into x into x per x in range 5, only 5. I didn't need to write anything else. Print numbers n equal to x into x per x in range 5. That's good. Print n. Oh, suggestions is a little bit bad. The square bracket. I need to here is square bracket. Here it didn't need square bracket. Print n. Per norm in gen. Print norm. So here it didn't, uh, as you see, per norm in gen, print norm in generator x into x, but x in range, for any. Oh, okay. By the way, we can also create generator like this, uh, using parenthesis also. Uh, so we can use square bracket and parenthesis as you want, but generally prefer parenthesis. This is called generator expression, as we learned it. Generator expression. It works the same way as a generator function, but it's shorter. Uh, so let's run it and see. Oh, good. No, no, it is same way, but the expression is different. We use parentheses, square bracket, if you want to enter. That's good. Let's create another one here. Here we didn't need to create another file here. Create a, let's talk about infinite generator. How infinite generator works. Generator. Generator. Let's talk about uh, number. What's, oh, I need to say number. So infinite, we didn't say number. We said numbers. N equal to 1, while true. This true keyword uh, it infinite generator, but it is can basically it can crash. Why? We can see when I in past file where we run print next and sixth time, that is an error. Are you remember it? Let's comment it. I can see right one right now. So here's again n equal to infinite number. for I in range. Don't range, it is Jane basically. I in Jane. Bench. I have. Uh, we'll talk later about this special print. I don't see the suggestion, so don't see it. You don't need that one. No, as I'm a C++ worker, so generally you forget about. We didn't need bracket here. So let's talk about this. Written as we give it number, infinite numbers. Why it gives error and n. Oh, again spelling mistake. So now it's good. So we give it infinite numbers. So generator can even be infinite, meaning they keep producing value forever. This is useful for streams, live data, real-time process. When you run Chat GPT, are you using Chat GPT? Then you can see the conversation when the chatbot give answers to you. It gives one by one. It's don't take much time. It give instant answer and if one by one, letter by letter, write that because it use streaming, it use yield method in backend, so that it don't store a whole thing at once and give once, but it store uh, oh, one by one. When the answers comes, it's show you one by one when the uh, chatbot generate that. So let's run it, the infinite keyword. So this is useful for streaming uh, when we use real-time process forever. So let's summarize what we learned today. A generator is specially here is let's a generator is special kind of function that yields one value at a time. So it uses yield instead of return. It remembers where it left of each time. It's called generator are memory efficient and perfect for working with large data infinite sequence. So that's it for today. Try practicing by creating your own generators. For example, one that yield even numbers or Fibonacci numbers. Thanks for watching and keep learning Python. Uh, let's see you tomorrow.